Now we start with the chapter of work energy, conservation of energy and collisions. This chapter is very important because all the concepts you are going to learn in this chapter is going to help you in the future chapters also. And this chapter also utilizes all the examples and concepts and formulas you learnt in the previous chapters of Newton's laws of motions and motion in a plane and motion in one dimensions. So let us start with the examples. This is an elevator going up with an acceleration of a meters per second square. Initial velocity of the elevator was 0. We have a mass m hung by a string from the roof of the elevator. We want to find the work done in t seconds by the tension in the elevator. For this, let us first find out the tension in the elevator. For finding out the tension in the elevator, we write the equation on this mass m. Tension acts above, mg below, the acceleration is a. T minus mg is equal to ma. Therefore, the tension is equal to m into g plus a newtons. So we now know the tension. The tension in the string is constant. Now whenever the force is constant, we know the formula for work done directly. The formula for work done in the case of constant force is force into displacement directly. If the force is not constant, you will have to integrate the force, that is integration f ds, to find out the work done by the force. Now in this case we can do it directly since the tension force is constant. Now we'll find out the displacement of this mass m in t seconds to find out the work done by the tension. Now the displacement of the mass m is initial velocity is 0, acceleration is equal to a, time is equal to t seconds, so displacement is equal to half a t square. Now the work done by the tension acts in the upward directions. The displacement of the point of application of force. We'll always remember the formula for work done as force into displacement of point of application of force. Now the point of application of force is displaced by half a t square. So the work done comes out to be force into displacement. Actually the formula for work done is F vector dot displacement vector. Now here, since force vector and displacement vector are both in the same direction, the angle between their tails is 0 degree. So we can directly multiply their magnitudes to find out the work done, because cos 0 is equal to 1. Now when we multiply the tension by the displacement, we directly get the work done by the tension force, which is equal to m into g plus a into a t square by 2. This comes out to be the final work done by the tension force on the block.